Hey guys, welcome back. Chapter 5.2 Ecological Succession. Now this might be a new term, not too sure for you, but ecological succession, the normal gradual change in the structure and species composition in a given system. The system here is typically, obviously, a ecosystem. We're going to talk about two types primarily. Primary ecological succession and secondary ecological succession. I'm going to throw two different pictures up and kind of talk you through them. But for me, my definition of primary and secondary, primary ecological succession, no soil. For some odd reason, if you're trying to figure it out, you're reading a scenario, if there's no soil to begin with, it's primary. If there was already soil, dirt with nutrients and stuff in it there, then it'll be secondary succession. So let's look at primary succession. Now the picture up here is showing we're starting with rock. Now for primary succession, for some odd reason, there was no life there before. A glacier has retreated and the only thing left under there is rock and rubble. A volcano has erupted and now it's just a lava island. Well, those would be nature things that created it. Yeah, there was nothing there but rock, glacier retreats, or lava. These are classic nature primary. Well, if humans go in and they lay down a big parking lot, think Walt Disney World parking lot, well, is that much different than a lava flow? So in somewhere like a parking lot, that could actually be primary succession. But no matter what, for whatever reason, there's no soil there. Primary succession tends to start off with some early species come in. These early species that tend to come in are lichens and mosses. We call them pioneer species. Pioneer, they're the first there. They tend to show up. Now they can get blown in, drift in, come in off of spores. A bird could come by, fly in, drop some. But moss and lichen, because they don't need soil, they grow right on the rock. So as they begin to grow, their little root structures hang onto the rocks, cause the rocks to break off, chip a bit. As the lichen also flakes off and dies, that's the organic matter that can begin to be the bit of soil. So after lichens and moss come into an area, then we start to get some small herbs and little bushes and shrubs, and that will move into, a little bit bigger shrubs. We start to get a little bit bigger layer of dirt. Then we tend to start getting things like pine trees in, and eventually, after possibly centuries, because it all depends on the area where this is happening. Is it kind of tropical and wet, or is it kind of cold and dry? But if this is in a moist, warm environment, well, we could be looking at a few hundred years before I can start getting into pine trees and then this established forest. It can be anywhere from hundreds to thousands of years, depending, to go from primary all the way to a complex ecosystem. So this is primary if we're starting in nothing but barren ground. Another way primary can happen is in a lake. Now at the bottom of the lake, we don't really have any kind of sediment. There's really nothing there if it's a big enough lake. Well, what happens is you have algae, things grow on the surface and they come in and they die and they go to the bottom. So the lake starts getting shallower and shallower because it's filling up with all this dead matter from algae, from other plants. Things blow in, leaves, etc. I have a koi pond at my house, and every year I got to scrape off the bottom and get all the dead leaves that are falling down into the bottom. They start to create a soil. So my pond starts getting a little shallow, so I have to maintain it. But if we're not doing anything, eventually the lake can fill in complete with sediments. And it kind of looks like a wetland for a while, and eventually I can get growth in it. And I wind up with an actual terrestrial biome where it used to be an aquatic one. But this is, once again, no soil, primary succession. It can come from on land, once again, volcano or a glacier retreating are the classic, but it could also be a parking lot that was man-made. Or I have a aquatic ecosystem that can turn into a terrestrial one. Once again, they take a long time to go from primary. Secondary succession. Secondary ecological succession, soil present. Soil present. For some odd reason. There's a series of terrestrial communities or ecosystems, and they develop in places where there is soil or sediment already present. For instance, an abandoned farmland. Well, if it's farmland, somebody went and cleared it all off, and then we were growing corn, or we were growing sunflowers, etc., but it gets abandoned. The farmer won the lottery. I don't have to farm anymore. And they let their farmland go. Well, this would be classic secondary succession. Nature begins to take over. There's already soil there. There's already some things in the environment. It could be from a forest fire. Forest fire, horrible forest fire. It comes through, burns everything out. So there's nothing there. There's no plants, there's no trees, but there is soil. And in the soil, we still have some seeds. There's some stuff down there. Root system exists. Maybe it's a flood. A dam breaks. Flood comes through, washes and destroys everything, and I'm just left with the dirt. Secondary succession. It's a lot quicker and a lot easier for an ecosystem to recover if it already has soil there. If we have to create the soil first, that's a long, slow process. Now, how fast it grows back, there's a lot of things. The facilitation of the area by one species or another. Is there already something kind of there, ready to pop back up? Is there any kind of inhibition? Something that's going to inhibit growth. Pine trees are a great example. Let's say it did burn through and some pine trees stayed. Because they were really tall, it burned a bit of their bark, but the pine trees didn't die. Well, pine needles, when they fall to the ground, are acidic. If you've ever eaten a pine needle, I don't recommend this, but as a kid I was like, ooh, they smell nice. I wonder what, yeah, really kind of sour and bitter. They're acidic, and they make the soil acidic. And a lot of things don't grow well in acidic soil. So if there are pine trees, it might be an inhibitor. It might take longer for the forest to recover. Is there something inhibiting natural growth? And then just tolerance. Tolerance occurs when organisms are not in direct competition. Like I have a tree that's growing up high, but I have something that kind of likes to grow in the shade, like ferns. They're tolerant of the shade. So it can go a little faster if I have species that are tolerant of each other, as opposed to species in direct competition with each other. Once again, competition, harm, harm. Tolerance, more of a both get something out of it. So in this case, we have our secondary succession. Something happened. There was a forest fire, a flood wiped everything out, but the soil's still there. So pretty quickly, the grass kind of pops back up, and then we move typically into our taller grasses, into our shrubs. Pine forest, pine trees tend to grow very quickly, so they tend to pop up first, and the last tends to be, if we're in a forest type setting to begin with, tends to be these mature hardwood trees, oak, elm, sycamore, hickory. These are denser, harder, and they're slower growing trees. Pine trees grow really fast, which is why we tend to see them. Now, if we're in a really good setting, this is from that first little block might just be the first couple of years, and then the next 3 to 5 years, and then 10 to 15 years. A pine forest can come up in about 20 to 30 years. That very last section with the kind of red tree, we're looking at something like a maple and oak trees. That's probably going to be at least about 150 years to go from secondary succession, from it was wiped out to back to a hardwood forest. Once again, presuming we're in a deciduous forest climate to begin with. 2 to 3 years, about maybe 7 years, 10, 12, 20 to 30 for the pine forest, but up to 150 years to get to the last one, if you will. Now we're going to bring up a thing that people talk about, a balance of nature. You may have even learned before we talked about that last one as a climax community. Well, that was really an old view of things, where we talked about ecological succession goes from these certain stages until it reaches its climax community. This is a community in perfect balance, exactly as nature intended it. Well, our views on that are changing. We don't really believe anymore that nature has a plan and this is the ultimate community that it's trying to get to. This idea of equilibrium, balance of nature. In reality, there's always struggle going on. There's always change taking place, and nature's just dealing with what's thrown its way, and it's balance. It's not really going to get to a balance. It's just getting to where it's existing with its current state of change. The current view, instead of referring to it as a climax community, is just saying succession leads to a more complex, diverse, and resilient ecosystem. Resiliency is really kind of the key, what we're after. In other words, it can withstand changes if they're not too large or too sudden. So a more complex, diverse, and resilient ecosystem is one that can withstand change better. Now, all these living systems are sustained through constant change. There's change going on all the time, whether it's changes in climate, changes in the organisms that are there, invasive species come in, other species die out. This is just the nature of life. And it's not always humans that are bringing invasive species in. A hurricane brings one in. A bird drops one in. Nature does it itself all the time. The ecological inertia or ecological persistence, I personally like persistence, is the ability of a living system to survive moderate disturbances. You know, something comes in, a beetle does come in that begins to destroy certain trees. What is the ability of that ecosystem to deal with it? That is its persistence. A good, healthy ecosystem tends to have good persistence. Also, resilience. Resilience is the ability of a living system to be restored through secondary succession after a disturbance. So resilient, you know, once again, something does come in and disturb. Maybe a forest fire comes through, maybe a flood does come through. Its resilience is its ability to restore itself after a moderate disturbance. Now, some ecosystems have one, but not the other. Let's look at a rainforest. Now, rainforests have classically bad soil. All the nutrients are actually in the trees, because inside the trees, you have the epiphytes hanging onto the trees as it rains. The nutrients exist mainly above the soil line. The soil is classically bad in a rainforest. So, we go in and we cut down a section of the rainforest, a moderate disturbance. You wouldn't cut the entire rainforest, but we cut a chunk of it out. Well, once we remove the vegetation, the rainforest isn't very easily able to recover there because all the nutrients were in the vegetation. We take the vegetation away and now we leave it alone. The rainforest may never come back there because we don't have good soil. And without the good soil, rains do still come and they wash the soil away, and I'm not left with anything. So rainforests do not tend to be very resilient. They do, however, have good persistence because they're very diverse. They have great diversity. So if something comes through, but you cut down a chunk of it or it gets burned out, and they're not very resilient. Unlike a grassland. Now, grasslands are not that persistent, if you will. There's not a lot of variety. There's just this kind of one or two different types of grasses. So if something interferes, if something causes death to those types of grasses, the grassland is not very persistent. It doesn't have a lot of diversity, but it's incredibly resilient. A forest fire comes through, burns the whole thing down. Well, all the nutrients are in the soil and in the root structure of the grass. and within a couple of weeks the grass is sprouted back up. Within a few months it doesn't even look like the fire happened. Incredibly resilient, can snap back like that. So we have persistence, tends to be high diversity, and something can survive these moderate disturbances, or resilience, which is where something can restore itself very quickly in secondary succession. Rainforest, good persistence, not very resilient. A grassland, once again, if something disturbs the type of grass, it's not very persistent, but it's incredibly resilient. A couple of different ways to look at it and think about it. Succession, primary succession, secondary succession. Remember, we're going with this, not really the idea of the balance of nature or equilibrium or a climax community, but instead more complex, more diverse, persistent, resilient. That wraps us up for section 2. We will see you next time when we talk about the limits to a population's growth. Take care, guys.